I'm going to go through some problems with you, and you're going to need your periodic table, your star chart, okay, because you need the charges, and then you're also going to have to, if you flip it over, you're going to have to reference the polyatomic ions, as well as on this side, the activity series. So if you need a minute, go ahead and grab your periodic table. This paper, predicting products, instructions, and examples, and this worksheet. Practice problems, balancing equations, part 1. There's 3 parts to this, and it's progressively going to get more difficult. But right now we're just going to start with balancing equations. Can anyone tell me what the law of conservation of mass is? What exactly does that mean? Okay, the law of conservation of mass is going to be matter or atoms is neither created or destroyed. Okay, so you can see this in different forms. Sometimes it's a diagram of pictures. However many molecules on one side of the arrow, okay, here's the arrow. However many molecules that are on one side, this is the reactant side, has to be the same on this side as well. So if there's 2 chlorines right here on the reactant side, then there has to be 2 chlorines over here on the product side. And that's what the law of conservation of mass is, and that's why we balance equations. To begin, I always draw an arrow. I'm going to zoom in a little bit. Where the arrow, I always draw a line where the arrow is, all the way down. And that just helps me organize my work on what side is the reactants and what side is the products. So the left side of the arrow always will be your reactants. After the arrow will be your products. And that is always, that goes for every single chemical reaction. Here's one way to balance, and if you have your own way to balance that you're more comfortable with, then go ahead and do it your own way. Okay, I put 2 CLs because this little subscript means I have 2 CLs, okay? 1 NA and then 1 BR. And on this side, 1 AR, 1 CL. And again, there's 2 BRs because if you look closely and if you look at your paper, there's a subscript connected to the BR, and that only represents the number of atoms for BR. So as we compare both sides, are they even? No, they are not. There's 2 CLs here and only 1 CL on that side. It needs to be equal. So I'm going to start off with putting a 2 here. By putting that 2 there, it says I have 2 NAs and 2 CLs. So it goes for both of them. 2 NAs, 2 CLs. Now are we equal on both sides? No, we are not. I have 2 NAs over here and I only have 1 here. So on this side, I'm going to put a 2. And you always start off with 2. You know, you may have to cross it out and if it affects other things and go back and forth and increase the number. But you don't start with 1, you always start with a 2. By putting that 2 there, I now have 2 NAs, and that 2 applies to the BR as well. Let's see if we are even. 2 CLs, 2 CLs, 2 NAs, 2 NAs, 2 BRs, and 2 BRs. That's the balancing portion. And on the right of the problem, it says type of reaction. So what kind of reaction was this to begin with? From the booklet we made, I'm counting the number of elements I have. 1, 2, 3. There's 2 different ways you can identify, or 2 clues or hints. There's 3 elements, or you can look at it and say you have a loner or a single element. Sometimes I say a single person. Always alone. Okay? There's 3 elements. That's the other clue. Anybody have any ideas of what type of reaction that is? Right. It's going to be a single replacement. We'll go ahead and balance one more before we go to part 2, which is going to be predicting the products. Okay, so the lines down the arrow to separate the reactants and the products. This is how I balance. If you have another way, then continue to do it your way as long as you're getting it right. And just to clarify, on the very top for number 1, the coefficients were 1, 2, 2, 1. So in a multiple choice exam, it might be listed like that to ask you what the coefficients are. 1, 2, 2, 1. 1, 2, 2, 1. You go left to right. Okay, back to number 2. 1 Hg, 1 O, 2 Cls. Why did I put 2 Cls? Anybody? Right, because there's a subscript and it's 2. So that 2 applies to the chlorine atom only. Let's look at the product side. 1 Hg, 1 Cl, 2 oxygens. And now we're going to compare both sides. Are we even? Okay. No, over here there's 2 oxygens. There's only 1 over here. So we are going to start with putting a coefficient of 2. By putting this 2 here, I now have 2 Hgs and 2 oxygens. Please remember that if it's a coefficient in front of a compound, it applies to all the atoms. Okay, that's why the 2 goes for the Hg and the 2 goes for the O as well. It's not just for the Hg, it goes all the way through. So now I have 2 Hgs, 2 Os, 2 Cls. So I'm going to compare to the other side. Okay, this side needs some Hg and Cl, so I'll put a 2 here. I have 2 Hg. How many Cls do I have now? Okay, 2 Cls, 2 Hgs, 2 Cls, 2 Os. Are we even now? Is the equation balanced? Is it following the law of conservation of mass? Yes. What type of reaction is this? I personally always just count the elements. 1, 2, 3. Sometimes you run into problems with counting the elements because polyatomic ions, they're 2 capital letters and you're not sure if they're together or apart. So the other way you can tell what kind of reaction is that you're always going to have one that's all alone, a single one. This makes it single replacement again. Okay, so if we look at the coefficients all the way across, it's 2, 1, 2, 1. So on a multiple choice exam, oops, it might be listed like that. And I'll show you again. 2, 1, 2, 1. So 2, 1, 2, 1. Okay, I want you to practice on your own balancing 3 through 6 and naming the types of reactions. Turn the paper over. Okay, don't turn the paper over. There's nothing on the back. Part 2, here we go. Single replacement reactions worksheet. Predict the products and balance the following single replacement reactions. If no reaction occurs, write NR, and for transitional metals, use the following charges. If we look at our periodic table, don't forget the transitional metals were the ones that are in this center region that's outlined in turquoise. These have multiple charges. So that's why on the worksheet they gave you the charges to use for these certain transitional metals. Again, you're going to want to review really quick the 3 rules for predicting the products and just get in the habit and follow this pattern. We're going to predict the products first. We're going to butterfly the charges, so we'll have to use our periodic table. And then we are going to balance the equation. That's the last thing. Balance the equation so it's equal on both sides of the arrow. Okay, let's start the worksheet. So they already told us what kind of reaction it was, single replacement. So we are going to see if Fe will replace Cu. So will iron replace copper? For every single replacement predicting products, you're going to refer back to these activity series. If you have your periodic table, you can just make a note that for single replacement. Okay, always. Can anyone explain to me how do we use the activity series? Okay, how do we read this? Does anybody want to try? I'll give you an example. So let's say in the single replacement problem, any of these problems, you are only allowed to replace another element if you're higher on the totem pole. So can sodium replace potassium? Can sodium replace potassium? No, it can't, because potassium is higher on the activity series. So you would write no reaction because no reaction would occur. Okay, but can sodium replace zinc? Okay, yes, because sodium is higher than zinc. And that's how you're going to use this. And you always start off with the lone element. So what you're doing is you're checking to see if the ones that I circled is able to replace one of the elements on the right hand side. Okay, so the first two elements we're looking at are iron and copper. So I'm going to go ahead and look at my activity series and locate iron and copper. Can iron replace copper? So I'm looking for iron. Iron is right there. And then copper is below it. So that's great. Iron is right there. Copper is down below it. So yes, iron can replace copper. So iron is literally taking the place of copper and making copper be the loner. Okay? So you can write it Fe, C, L. Okay, so that's step one. We just predicted the products. Now step two is to find the charges on the periodic table. So the charge of Fe, it told us at the very top to use +3. So I'm going to write +3. I'm going to zoom in as well so you can see this better. And then the charge for Cl, look to your table. Here's chlorine. The charge is -1. Cl is -1. Copper, it tells us at the very top for copper, use the charge +1. Now we're going to butterfly. If you don't remember this, then it's time to just practice. That's the only way you're going to get better. Okay, so the 3 is going down to the Cl's. So when it's all said and done, and I rewrite this, it's actually going to be okay. Oh, sorry about that. So not this one. That was kind of just my rough draft. As you get better, you might not have to do that separately, and you can always use an extra sheet of paper. So the two equations I'm balancing, the reactants and the products. Again, a coefficient line is not always drawn for you. I sometimes just get in the habit and draw it in myself. And you can go ahead and do that as well. Okay, so I'm going to draw the line where the arrow is so I can separate the two. It helps me stay organized. I have one Fe, one Cu, two Cls. I'm going to do the same over here. I have one Fe, three Cls, and one Cu. Why on this side do I have three Cls? What is it? Yes, it's a subscript attached to the chlorine only. If it's a subscript, it only applies to what it's attached to. So over here, I need some more chlorines because I only have 2 chlorines right here. So I'm going to put a 2 here. By putting that 2 there, it also affects the coppers. So now I have 2 coppers. 2, how many chlorines exactly do I have? Let's zoom in. Because the coefficient's a 2, how many chlorines do I have? You have to consider this too as well. Very good, Haley. There's 4 chlorines. Okay? So now let's compare. Are we even, Steven? No, we are not. Because over here I have 3 chlorines. So I'm going to start with putting a 2 here. It does affect iron, but you have to do it. So regardless if it affects other elements, you're going to have to start there and make adjustments on the other side. So now I have 2 irons. 2 irons. How many chlorines do I have? Don't forget that that 3's there, and the 3 only applies to the chlorine. So that's when you multiply. So I have 6 chlorines total. Okay, so 6 chlorines are on that side, 2 irons, and 1 copper. I can go ahead and even out, let's see. I'm going to have to put a 3 here. And it's very common to go higher than 2. Okay, so use pencil if you have pencil, or you're going to have to cross it out a couple times. So how many coppers do I have now? 3 coppers, and how many chlorines? Because chlorine has the subscript attached to it, you do 3 times 2. So now I have, on this side, 1 iron, let's see, 3 coppers, 6 chlorines. Over here I have 2 irons, so I'm just going to add a 2 there to give me my 2 irons. So my irons are even, my chlorines are even, but I have 3 coppers on this side. What number do I need to put? What coefficient do I need to put on this side? I would have to put a 3. This does not mean add 3 more chlorines, okay? This just represents that you have add 3 more coppers. Just represents that you have 3 coppers total. So let's see if we're even. Excuse me. 2 FEs, 2 FEs. 6 chlorines, 6 chlorines, 3 Cus, 3 Cus. And I'm done. Okay. Predicting products does take a little bit of time. I recommend you use your own piece of paper. And another tip I would give you is don't forget to draw a line for coefficients if necessary, because it's not always there and it could be confusing for you. So go ahead and practice the rest on your own. If you need help, rewatch the video and come and see me.